Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. Now, it takes many billions of years to create a galaxy like the Milky Way galaxy.
And we are certain that the visible portion is a tiny portion of what might be an infinite cosmos beyond. We're not sure. In actuality, the universe is a vast system composed of innumerable, disparate objects. Even light can be lost in their depths due to their extreme separation in the emptiness of space. It takes more than 4 years for a photon from the sun to get to the star closest to you. Getting through interplanetary life can take millions of years. It's really astounding when you consider that this enormous area is only a small portion of the universe's size. What is the actual size of the cosmos, then, and what is out there? Brian Cox, a well-known physicist, recently expressed his opinions and made startling discoveries. Come along with us today as we investigate the size of the cosmos and its potential. There are a lot of things about the cosmos that I just can't even begin to conceive, let alone believe. One is simply its size and scope. I mean, there are around 2 trillion galaxies in the portion of the universe that we can see. 2 trillion, 2,000 billion galaxies are estimated based on scans of the nearby cosmos. We haven't counted them all. While the Milky Way contains 400 billion stars, each galaxy is roughly the size of the Milky Way, with some being larger and others smaller. There are 2 trillion galaxies in the portion of the universe that is visible to us, and it takes light more than 100,000 years to go through one. And we are certain that the visible portion is a tiny portion of what might be an infinite cosmos beyond. In fact, we don't know. And I always tell them not to worry about that since no one can imagine it. The universe's size is inconceivable to imagine. That is the first thing, then. I could go on for a long time, but for the time being, we'll stop there. However, I believe that the sheer magnitude and scope of it is unimaginable. There are several planetary systems dispersed around our galaxy, including our own solar system. It is made up of 8 planets and their moons, as well as 1 star in its main sequence stage. Furthermore, there are more than 1 million minor celestial bodies in our solar system, including meteoroids, comets, and asteroids. With an orbital radius of around 30 astronomical units, or 4 light hours, Neptune is the farthest planet in our solar system. Interestingly, Neptune's orbit actually only encompasses a small portion of the solar system. Far out, which is 132 astronomical units, or 18 light hours, from the Sun, is the farthest object yet found in our solar system. The fictitious Oort cloud, whose inner bounds are thought to be about 2,000 astronomical units from the core of our solar system, is still far away from even this object, which is hardly discernible against the immense darkness of space. According to some estimations, the Oort cloud's outer borders reach 60,000 astronomical units, or around 1 light-year. The gravitational force of the Sun defines these boundaries, while interstellar space is beyond them. Within 20 light-years of the Sun, we may identify more than 50 different kinds of stars. They range from bright, well-known stars like Sirius, Procyon, and Altair to dim, frigid brown dwarfs. There are few of these stars with planetary systems of their own that might harbor life. Of all the planets in our solar system, Gliese 832c, which is 16.1 light-years from the Sun, is the most like Earth. This exoplanet orbits its parent star in just 36 Earth days, and its typical surface temperature is roughly 253 Kelvin, or 20 degrees Celsius below zero. The distance to Gliese 832c is quite short from an astronomical perspective. On the other hand, a spacecraft leaving our solar system at about 17 kilometers per second would require about 300,000. It will take years to get to this exoplanet's neighborhood. Designing an interstellar spaceship that can make such a long journey is not possible at our current technical level. The Milky Way galaxy's Orion arm, which includes our solar system and its nearby stars, is home to some 400 billion stars and maybe more than 1 trillion exoplanets. According to current estimates, The Milky Way's main disk is about 1,000 light-years thick, and its main diameter is approximately 100,000 light-years, with a stellar halo potentially extending twice that distance. The galaxy's center features a noticeable bulge that is roughly 3,000 light-years thick. The Milky Way is a component of the Local Group, a massive structure made up of around 50 galaxies gathered in a region of space that is roughly 10 million light-years across. The Milky Way itself, the Andromeda Galaxy, and the Triangulum Galaxy are the biggest galaxies in this group. According to some estimations, the Milky Way and Andromeda are mostly responsible for the cluster's mass, which could total approximately 3 trillion solar masses. Apart from minor dwarf galaxies, Andromeda is our closest galaxy, with a distance of roughly 2.5 million light-years from Earth. On a larger scale, the Local Group is a component of the vast Virgo supercluster, which is made up of more than 30,000 galaxies. With a total mass that might reach a quadrillion solar masses, or around 1,000 galaxies the size of the Milky Way, this supercluster covers a region of space that is about 150 million light-years in diameter. About 60% of the supercluster's constituents are arrayed on a flat sheet that is about 10 million light-years thick, indicating how flattened out the cluster is. Despite its seeming grandeur, this pales in comparison to the universe's vast structure. Zooming out even farther, we come across Laniakea, a massive supercluster of galaxies that spans around 520 million light-years. Several galaxy superclusters, such as the Great Attractor and the Virgo supercluster, are part of this structure. An estimated 100 quadrillion solar masses make up Laniakea's total mass. Approximately 250 million light-years away from Earth, the Great Attractor serves as a gravitational hub for everything in the area. Since the Milky Way blocks our perspective, it is not immediately observable from Earth by astronomical standards. This is why the nature of the Great Attractor remains an unsolved enigma today. A complex network of galactic filaments, barriers, and voids, vast areas of emptiness in space, make up the large-scale structure of the cosmos, of which Laniakea is a part. A few of these constructions are really large. The Hercules Corona Borealis Great Wall, for example, is an incredible 10 billion light-years long. This superstructure has been considered the biggest part of the large-scale structure of the universe since its discovery in 2013. It is thought to contain millions of galaxies, and it is probably impossible to calculate how many stars there are in all. Since large clusters like this shouldn't grow according to existing ideas of the universe's history, the very presence of such a structure is a mystery to scientists. Surprisingly, this wall, so huge that the human mind finds it difficult to imagine its size, remains a tiny portion of the universe as we know it. According to contemporary cosmological theories, the universe's space is continuously expanding, with the rate of expansion changing according on the separation between things. The viewed object is moving away from the observer at a faster rate the farther it is from the observer. Since space itself is growing, this rate of separation is not limited by the speed of light. Consequently, the two things will eventually cease to be observable to one another. The observable universe is a spherical region with a diameter of about 93 billion light-years, according to relic radiation observations. Only within this sphere are we able to see and interact with objects, according to the theory of relativity. The term metagalaxy refers to this typical spherical region in space, which could include the entire universe or only a small part of it. Theoretically, there might be unidentified structures outside of space's apparent boundaries. These formations are referred to be extrametaggalactic objects, and regrettably, we are unable to do scientific research on them at this time. But according to the data we currently have, some celestial bodies at the frontier of the observable universe appear to be traveling in ways that are inconsistent with our assumptions. Such unusual motions could be a sign of the existence of enormous structures outside the metagalaxy's borders, whose gravitational pull would affect objects close by. Though many of them are metaphysical in nature, there are many hypotheses regarding the structure of the cosmos outside of the metagalaxy. For example, some people think that space and time as we know them don't exist outside the confines of the cosmos. Concepts like matter, substance, and energy lose almost all of their significance there, and the physical principles we are accustomed to do not apply either. This argument is further supported by the notion that the metagalaxy is merely a part of a larger and more complex superstructure in space, whose size and makeup are beyond our knowledge, but it's suddenly quite likely. This structure might be built on as yet undiscovered physical principles or exist in multidimensional space. As a result, the metagalaxy might be merely a minor complement to this incredible superstructure or a partial mirror of it. According to some interpretations of the anthropic principle, the observable universe is not the only world. Fundamental constants like the speed of light or the charge of an electron can have completely different values in these worlds. This concept is consistent with the multiverse, which is sometimes depicted as a network of bubbles divided by slender, impassable walls. Then, every universe would be a unique place with unique physical laws, some of which might be very different from the ones we currently understand. The most extreme views even contend that there is no objective reality in our universe. These perspectives hold that the cosmos is like a simulation, much like sophisticated virtual reality. The presence of superbeings or civilizations outside of our normal reality, beings whose achievements greatly surpass our own and whose objectives and capacities remain mysterious and unfathomable, is usually implied by such notions. But it's almost tough to prove or disprove these theories. Undoubtedly, the enormous distances in space can be intimidating and test our ability to imagine. From anyone's point of view today, they appear limitless. We are aware that the universe is expanding, and if this trend persists, celestial objects will eventually disappear beyond the event horizon. Galaxies will vanish first, followed by stars, leaving the universe in a state of perpetual gloom. However, nobody will be around to see it by then. Philosophers, scientists, and intellectuals have always been captivated by the pursuit of knowledge about the cosmos beyond our own. The brainworld scenario and the multiverse theory are two well-known hypotheses that make an effort to explain the nature of existence outside of the observable universe. The theory of the multiverse. According to the multiverse theory, our reality is but one among many that coexist in a vast cosmic landscape. The term multiverse is frequently used to describe this collection of realities. Physical rules, constants, and even dimensions may vary between the multiverse's universes. Different interpretations of cosmological theories and quantum mechanics give rise to the idea of the multiverse. For instance, according to the many-worlds interpretation of quantum mechanics, each quantum event causes the cosmos to branch out, creating an ever-growing number of parallel realities. According to this theory, every choice or incident has the potential to create different realities, enabling an endless number of universes to live with our own. The multiverse theory is influenced by quantum mechanics as well as cosmic inflation, which is the fast expansion of space following the Big Bang. According to certain inflation models, distinct areas of space may create bubble universes inside a broader inflationary field by ceasing to inflate at various times. Independent evolution of each bubble might result in the emergence of unique physical characteristics. Others might have completely different rules of physics, which could result in worlds that are unfamiliar to us, while others might have traits that are comparable to our own. The multiverse theory has significant ramifications. If this is the case, there could be an endless number of different realities, as any scenario we can think of exists in some universe. A person may choose a different career path in one world, while historical events may transpire differently in another. The nature of fate and choice is called into question by the possibility of parallel universes. The idea of free will gets more complicated if every choice results in the formation of a new universe, as every potential consequence occurs in various realities. The multiverse theory's detractors claim that there is insufficient empirical support for it. Testing or seeing other worlds is challenging, if not impossible, due to the multiverse's breadth. This restriction calls into doubt the theory's scientific viability. Since the multiverse questions the idea of a single observable reality, some skeptics argue that it is more philosophical than scientific. However, proponents contend that the multiverse provides a framework for understanding some of the universe's seemingly inexplicable occurrences and is a logical extension of well-established physics theories. The situation in brainworld, the brainworld scenario, which emerges from string theory, is another theory that aims to explain what exists outside of our universe. According to string theory, the fundamental units of the cosmos are one-dimensional strings that vibrate at various frequencies rather than point-like particles. Beyond the well-known 3 dimensions of space, these threads can exist in higher dimensions, as well as one aspect of time. According to the brainworld scenario, the bulk is a higher dimensional space that contains a 3-dimensional brain. This hypothesis suggests that the bulk has other dimensions that are inaccessible to us but have an impact on how our universe behaves. Other brains, each representing a distinct cosmos, might likewise exist in this higher dimensional framework. Other brains might have their own special physical rules and dimensions, just as our brain is a unique thing. One plausible explanation for why gravity is weaker than the other fundamental forces is that the interactions between these brains could cause things like gravity to leak into our world from the bulk. The brainworld scenario now has intriguing ramifications for how we think about cosmology and the universe's beginnings. According to one theory, our universe was created when 2 minds collided in the bulk, releasing energy. This is known as the Big Bang. According to this theory, the dynamics of other brains may be linked to the events that transpired in our universe, providing a deeper comprehension of cosmic evolution. Interesting possibilities for dark matter and dark energy are also presented by the brainworld idea. According to some scientists, these enigmatic elements of our cosmos might be signs of gravitational interactions with other brains. If this is accurate, then dark matter and dark energy are results of the existence of other brains in the bulk rather being inherent characteristics of our universe. This viewpoint supports the notion that the dynamics of the cosmos are shaped by interactions between brains and that our universe is but one piece of a larger cosmic puzzle. Both the brainworld and multiverse theories stretch the limits of our knowledge and question accepted ideas of reality. They challenge us to reevaluate both the essence of existence itself and our position in the universe. However, these theories also raise philosophical issues regarding the nature of observation, knowledge, and the boundaries of human comprehension. What does the existence of higher dimensional brains or numerous worlds indicate for the importance of our own universe? Does our experience have inherent significance within the enormous cosmic framework? Or are we merely observers in an endless tapestry of realities? Now, as our knowledge of physics advances, so does our investigation of the cosmos beyond our observable realm. In this field, knowledge acquisition necessitates a readiness to accept ambiguity and take into account concepts that could appear illogical or even magical. It generates awe at the complexity of the universe and fosters an attitude of inquiry that goes beyond conventional bounds. The boundaries of human vision must be considered while pondering the nature of life outside of our cosmos. Though the theories of the multiverse and brainworlds imply a reality that may include dimensions we cannot directly perceive, our senses and tools are made to investigate a 4-dimensional world. This restriction brings up fascinating issues on the nature of knowledge and the function of human investigation. Are scientific studies only attempts to understand a portion of a much larger tapestry? Or can we really comprehend a reality that exists beyond our perception? When talking about what exists outside of the universe, the interaction between philosophy and science becomes very pertinent. Theories like the multiverse and brainworlds push the boundaries of our cognition and contradict our accepted view of reality. As we attempt to solve the mysteries of existence itself, we find ourselves at the nexus of philosophy, science, and existential inquiry. In the end, the brainworld scenario and the multiverse theory both provide convincing frameworks for comprehending what happens outside of the cosmos, but they also shed light on the deepest unanswered questions. Forces and occurrences that defy our comprehension have woven the cosmos into a vast and mysterious tapestry. We are reminded of the universe's beauty and complexity, as well as our role in it, as we continue to push the boundaries of knowledge. It's becoming more and more obvious as science advances that the cosmos might be much more complex than we can fathom. The theories of the brainworld and the multiverse are potent reminders that our knowledge of the world is still developing. Every new finding piques our interest and inspires wonder about the universe, leading us farther into the unknown. Therefore, the quest to learn more about the universe's outer regions is a voyage that goes beyond the realm of science. It challenges us to reflect on our lives, explore the nature of reality, and welcome the mysteries that are just beyond of our grasp. We set out on a journey that binds us to the universe and to one another while reminding us of the universal human experience in the face of the infinite as we investigate the depths of the cosmos and the possibilities that await us beyond. We appreciate you being here with us today. If you would like to see more content like this, please subscribe and leave a comment below.